Section 4.7 is on the introduction to coordinate proof. A coordinate proof is a style of proof that uses coordinate geometry and algebra. So we are going to be graphing and also incorporating some algebra topics in here. So the first step is to position the given figure in the plane. So we have to put it on the coordinate plane. And some strategies can make the steps of the proof simpler. So we have 4 strategies here. The first one is to use the origin as a vertex. So putting one of the points at 0, 0, and then keeping the figure in quadrant 1. The next one would be to center the figure at the origin so that the origin is in the exact middle of your figure. The third one is center a side of the figure at the origin. So just one of the sides is, the middle of the side is at the origin. And then the fourth is to use one or both axes as sides of the figure. So for example 1, we are told to position a rectangle with a length of 8 units and a width of 3 units in the coordinate plane. There's lots of different ways to put this figure on a coordinate plane, and we're just going to look at 2 different ones. So the first thing says use the origin as a vertex, keeping the figure in quadrant 1. So that means that one of the corners of this rectangle is going to be at 0, 0. Its length is 8 units. So if we want to keep it in quadrant 1, remember that's where everything is positive. That's this quadrant here. So 8 units long would put the other vertex there. So that is one side of it. And the width is 3 units, so it would go up 3. So this would be our rectangle here. Another way would be to center a side of the figure at the origin. We could look to see if it's going to have a length of 8 here, then we could put 4 on one side and 4 on the other. So that's still going to have a length of 8, but it's centered at the origin, and then it'll be 3 high. So we could do that. So depending on what we're having to prove, depends on which position you want to pick to where you want to graph this. So like I said, there's lots of different options of where you could put it on the coordinate plane. Once the figure is placed in the coordinate plane, we can use a few different things to prove statements about that figure. So one of those things is the slope, which is rise over run, the coordinates of the vertices, so the ordered pairs of those points, the distance formula, or the midpoint formula to prove. So all 4 things there we can use. So I definitely suggest writing down the distance formula and midpoint formula so that you have those. Example 2 says that we have to write a coordinate proof, and we're given triangle ABC has these vertices, and D is the midpoint of AC, and we need to prove that the area of triangle DBC is 1/2 of the area of triangle ABC. We can look at triangle ABC here, and we can tell that it is 6 units high and that its base is 4 units across. And we know that the area of a triangle is 1/2 times base times height. So that would be 1/2 times 4 times 6. 6 times 4 is 24. Half of that would be 12. So the area of the large triangle ABC is 12 square units. So we're trying to prove that triangle DBC is half of that. So now looking at triangle DBC, we know that D is the midpoint. We were told that, but we are going to use the midpoint formula to find the ordered pair. So remember, the midpoint formula is x1 plus x2 divided by 2. And then our y is y1 plus y2 and divided by 2. So we're looking at A and C. So those ordered pairs would be over 0 up 6, and this one would be over 4 up 0. I'm going to take our x values and add them together. So that would be 4 and 0 and divide that by 2. So 4 divided by 2 is 2. And then we're going to take our y's, which would be a 6 and a 0, and divide that by 2. So that would be 6 divided by 2, which would be 3. So the ordered pair for the midpoint is 2, 3. So thinking about that, if we go over 2 and up 3, that means the height of this triangle would be 3. And then we can see that the base is 4 because that is on the axis, and we can use that. So then we're going to find the area of that triangle. So half times base times height, and the base is 4 and the height is 3. So 4 times 3 is 12. Half of 12 is 6 square units. And 6 is definitely half of 12. So we have just proved that the area of triangle DBC is half of the area of ABC. A coordinate proof can also be used to prove that a certain relationship is always true. You can prove that a statement is true for all right triangles without knowing the side lengths. To do this, we need to assign variables as the coordinates of the vertices. So for example 3, we're going to position each figure in the coordinate plane and give the coordinates of each vertex. So A is a right triangle with leg lengths A and B. So if we think about our coordinate plane here, we know the origin there where the x and y coordinates meet are going to be going to form a right angle. So we can put our right angle there. Leg lengths A, so we could say that this is over 0 and up A. And this coordinate over here would be over B and up 0, because we go over B however far that is, and then we don't go up or down anything. And then of course the origin here, this other ordered pair, is 0, 0. And then a rectangle with length C and width of D. So again, oops, let's try that again. A little bit better. So we're going to add in a rectangle here. And the length is C. So this one we're going to go over C and up 0. This one we're going to go over C because it's in the same line there with that x coordinate, but we have to go up, and it says the width is D. So this would be CD. This ordered pair here, of course, is 0, 0. And this one would be over 0 and up D, the width, whatever that would be. And our last example here, it says that we're given angle B is a right angle in triangle ABC, and D is the midpoint of AC. And there's not a picture given to us, so we are going to draw this out. And again, if it's a right angle, I'm going to use that origin as the point of the right angle. And angle B, so that would be B, and we can call this A and this C. And D is the midpoint of AC, so D is going to be right here. The area of DBC, so triangle DBC is right here, is 1/2 the area of ABC, so of that larger triangle. So we have to go through and prove this, but we aren't given any information. I do know that this ordered pair is 0, 0. And thinking about the fact that I have to cut area in half for triangles, I want to use a number that's going to be easily used with 1/2. So we're going to think about those kinds of numbers. I'm going to use 2. So I have to make up a variable for the other points here. So for A, I'm going to go over 0. Oops, and I'm going to go up, let's say, to W. And then over here for C, I have to go over, and I'm going to say maybe to Z and up 0. So those are the ordered pairs that we know. So we're going to have to find the area of the large triangle of ABC. So we're going to do 1/2 times base times height. And how far we go over is our base. So to get to point C, we have to go over 2Z. So that length, that base is 2Z. And then our height is up 2W. We're going to have to go up to get there. And if we multiply the numbers, we have 2 times 2 is 4. Half of that is 2. And then we have ZW, and these are units. We don't know what they are, squared. And then we're going to have to use the midpoint formula. Remember, we add our x's together, divide it by 2, and then add our y's together and divide those by 2. So we're finding the ordered pair for point D here. So we have to use the points for A and C, and we're going to add our x's together. I'm going to change color here. Our x's would be 2z and 0, and I have to divide that by 2. So 2z divided by 2 is going to give us just z. And then our y's added together, we're going to have to add 0 and 2w and divide that by 2. So 2w divided by 2 is just going to leave us with w. So our ordered pair for our midpoint is ZW. So I'm going to go over Z and up W. So I really care about that Y value of that distance midpoint formula there. So this is going to be a W. Then we're going to find the area, because now we have a base and a height of that red triangle. So 1/2 times base times height. And the base, remember, we went over 2Z here. So the base is 2Z. And the height we just figured out was W. So if I multiply the numbers I have 1/2 times 2. So 1/2 of 2 is 1. And then I have Z times W. And that would be units squared. So now we have to compare the triangle ABC, the area, with the area of triangle DBC. And if we took 2ZW from the larger triangle and we cut it in half, 1/2 of 2 is 1. So then we would just be left with that ZW, and that proves that the smaller triangle is indeed 1/2 of the larger triangle.